Hello, welcome to another video. We're gonna be differentiating a complex function, and it is not just sitting there, it is sitting on top of another function that has exponents, and the top one too has exponents. Whenever that happens to you, do not start thinking of the product rule or chain rule or the quotient rule, because this is actually a quotient. Think of logarithmic differentiation, because that's going to make your life easy. If you try to go the way of what you know, quotient rule, for this one, things are going to get very, very complicated, very messy, and you're going to get frustrated at the end of the day, and there will be no answer for you to show. So if you want an answer, do logarithmic differentiation. Let's get into it. For logarithmic differentiation, you just want to introduce natural log and rewrite this. See what I'm going to say. I'm going to say let y be equal to this function, x cubed plus 1 to the 3/4 divided by x squared sine cubed x. Now you can see where I'm going. I'm going to take the natural log of both sides. If I take ln of y, it means I'm taking ln of this side also. Let's use a square. It's going to be x cubed plus 1 raised to 3/4 divided by x squared sine cubed x. Okay, but we know that when you have the natural log of a rational expression, you can write it as a difference. So I can say the right hand side could actually be written as the natural log of x cubed plus 1 raised to 3/4 minus the natural log of x squared sine cubed x. This you learned from pre-calculus or from algebra 2. You see, I have rewritten this expression this way. Right? Beginning to look easier. And we also know that we can rewrite this as being equal to 3/4 natural log of x cubed plus 1. And because this is a product, we can actually write it as a sum. We can write this as minus the natural log of x squared, let's put it in parentheses because of this minus, plus the natural log of sine cubed x. Now I can distribute this negative sign, but then I can bring down this. Actually, let's write it. Let's keep going. So we're going to say the natural log of y is equal to 3/4 natural log of x cubed plus 1, and this is going to be minus the natural log of x squared minus the natural log of, I'm going to write this, instead of writing sine cubed x, I'm going to write sine x cubed, because that's another way of writing it. So let's keep going. This is 3/4 ln of x cubed plus 1 minus, this power comes down here, 2 ln of x minus, this 3 comes down, 3 ln of sine x. And that's it. And that's ln of y. I have not done any differentiation, but I have chosen to rewrite this weird combination as something I can tackle one after the other. The question is, do I know how to differentiate this? Yes. What about this? Yes. What about this? Yes. And what's the rule for differentiation? For natural log functions, what I tell myself, which you should tell yourself, is it is the derivative of the argument divided by the argument. So if I differentiate, differentiating, I'm going to have, remember, is the derivative of the argument, which is y prime, divided by the argument, which is y. I go here, Because this is a constant, I leave it as 3 over 4. Then the derivative of the argument is going to be 3x squared divided by the argument x cubed plus 1. I'm done. Go to the next one. I'm going to write 2. The derivative of the argument is 1 divided by the argument x. Go to the next one. 3. The derivative of the argument cosine x divided by the argument sine x. Okay, what's left is just to do cleanup. Well, we know that y prime over y. In fact, I can multiply both sides by y so I can get rid of this y. So let's do that. So we have y prime will be equal to, and at the same time I'll be doing some cleanup. So if I multiply this by this, I'm going to get 9x squared over, I'm going to write 4, in fact I'll write 4x cubed plus 4, just to keep it that way, minus, this is going to be 2 over x, minus, well, we know that cosine x over sine x is the reciprocal of tangent, which is cotangent x. So it's going to be 3 cot x. Nice. Remember, we're multiplying both sides by y. Well, that's it. But you can't leave your y like this. What did we say y was again from the beginning? This whole function. So you just imagine using quotient rule and you have this, you're carrying this all around as you're doing a calculation. It would be a disaster. And I bet you may not be able to find this if you use the quotient rule. Try it. Okay, so we have y prime ultimately will be 9x squared over 4x cubed plus 4 minus 2 over x minus 3 cotangent x multiplied by, what is the y? This thing that we started with. That's insanely complicated. X cubed plus 1 raised to 3 over 4 divided by x squared sine cubed x. And this is y prime, sorry. That is the derivative of the original function. Never stop learning, because those who stop learning have stopped living. Bye-bye.